Okay, I've been thinking about this for a bit. Let's debug it. So let's go. We move our first value into our hard check, right? Then this is the import function. Then we move our RAM address to our RAM buffer. Move 0 to our RAM address, because we want to go through all the values that we've previously saved. So now what? Now we move 0 to our RAM address, yes. I already explained this. And then we check. If the value that we currently have sitting in our check register is less than the value that is currently sitting in the RAM, we place it. If this is not the case, we check if our RAM address is greater. Oh, there's the problem. Place it anyway. We add 1 to our RAM address. Not sure if this is correct. Because that means that it's currently the highest value. Place it anyway. Move our check to RAM. And then we don't necessarily want to go to export, because we only want that if RAM buffer is that RAM buffer. Greater than or equal to 15. Let's go with 15. I'm not 100% sure if 15 is the correct value. If it is less than or equal to 15, we go back to import. If it is not, we go to export. What does this do? Is this giving us different results. No, it is not placing the value. We move in to our check, correct? Import the import value. Then we move the RAM address into our RAM buffer. Then we move 0 to our RAM address. Right, this has to happen before we find the position, right? This as well. If the current value is higher, is lower, place it. If not, go one up. If the current RAM address is lower than the RAM buffer, go one up. That's the problem, because it's going to be higher than it's supposed to be. We can define a one-up function. And this is why it's probably, because this is what's going to make it a little bit difficult, right? because later on we are going to define functions that let us, or define a circuit that will let us basically jump back more easily than this. We will be able to call basically functions that we define. So okay, what if it's not less than? Then we place it anyway. We could go to place that will mean that this code is unreachable. And that means that we can never reach export. So, but this way it should actually import them in a sorted manner. No, it always... Why does it jump back? Where do we sub? We move 0. No, something is not working. But we're one step further. We move in onto our check register. There it is. Then we move 0 into our RAM address. Then we find the position. This is a problem. No, that cannot be. So in general, find post should move 0 to ADDR, add 1 until higher. No, why is that? Oh, this is so troubling. The RAM address to the buffer, move 0 to this. Then we check, is it less? It is not less. So it is higher, right? So if the RAM address is lower than the RAM buffer, add 1, which is not the case because it is 0. That means we place the value. Move RAM to delta RAM. Move the RAM address to delta RAM. Wait, okay, there's a mistake. Now we place. Move the RAM address to delta RAM. Then we move RAM to variable 1, 0. Then we move our check to RAM. Works. Then we move our 1 to our check. Let's not add 1 to RAM address. And import the next value. So the RAM address is 1. In theory it should be. Actually is. Great. Would be good if we displayed this in this link components. So now what? Now the RAM address is 1. We save it into our RAM buffer, which is 2. Then we go to 0. Check. Is the value lower? Which it is. So we should place it, right? As we do that. Now we move the RAM address to delta RAM. Move RAM to variable 1. Variable 1. Where are you? 8. So there's a problem. Because y is our variable 1 not holding the value that was previously 251, which was sitting in our RAM. Let's see. Oh, it's just now that we have... No, we never moved it there. Then we move variable 1 to the check register. This is working. Then we would repeat the process until we reach the highest position. Yes. Okay, there's definitely problems here. strange. Okay, place is buggy. Let's figure out why. Move RAM address to delta RAM. In theory, this should work. $251. So first of all, there's a 0 sitting in this. Then we move the check value into the RAM. And then we put the variable that was previously sitting in the RAM back into our check. So now we check if the RAM address is lower than delta RAM. Delta RAM is currently 0. Oh, this is place. This is correct. Wrong function. Oh wait, this is place. This is correct. This is the part where we have the mistake. Let's just put our stop here. It's probably the best idea. So we go to place. We have our position, which is delta RAM. Right? It is 0. Now we move the RAM, the value that is saved in the RAM, to variable 1. Now we move our check to RAM. Now there's, yes, the 251. And now we move variable 1 to our check, which makes sense. Because in case the current RAM address is lower or equal to delta RAM, we repeat the process. We go 1 up. See, now we have a problem because we cannot just call 1 up the way we previously were able to call it. But we can copy this. Call it 1 up 2. Back 2. And then we would place and this will never break the loop. So we would have to once again what does this do? This infinitely goes 1 up. So if the RAM address is greater than delta RAM, if it is still less, place else import. Sadly, we're still having problems. This is taking a while. Sorry about that. We're going to take another break. Sorry. Still, I hope you had fun. I'm not sure if we... I guess we actually made progress, because the find position function should be working correctly. Only problem we have to fix now is to make a working place function, because maybe we are we are giving it another shot. We are already we have a little bit more time. Let's go over time. So we move our RAM address to our delta RAM, right? Maybe herein lies the problem. Maybe we should do this before we place. So now we move our RAM address to delta RAM. And then we have another part. It's only a 0. Import the next value. Go one up. Still wrong. Actually having trouble in this level. We move our RAM address to delta RAM. That means we save our RAM address. Remember, delta RAM is supposed to be the difference between our buffer, like between the position. This is the position. Right? Well, we wouldn't one up the RAM address. This is the position that the new value sits. We'd have to check delta RAM against the RAM buffer. Do we need delta RAM? Is there a reason for delta RAM to exist? This is the current high value. This is where we save our. This is where we save our highest position. Let us call it pause. Because this is the position. Right. So once we place, right, we have the position. And this is the swap. So what will we check? If the position is smaller than the RAM buffer, we would one up the position. And move the position into the RAM address. Seems promising, right? It is wrong though. Why is 63 right there? Okay, the way we determine the position might be a problem in the way we determine the position, because 63 shouldn't be sitting here. And apparently we never output. Okay, at least we're move the RAM address to the buffer. First, we import. We get our value. Then we save the current RAM address into the buffer. And then we move 0 to the RAM address. And then we start. Okay, maybe we can go like this as well. This is interesting, we never jump back to find pause, right? Let's do it like this. If the value is less than the value that is saved in RAM, place it. If the RAM address is less than the buffer, 1 up the address. If the address is still lesser than the buffer, go back to find pause. If it is not, place it anywhere. Go 1 up and check if now it is the correct value. Actually, we should at this point. Oh, we can add another program page by this. I just copied all of it onto a new page. So if this the value is still less of the 1-upping, we would have to find the position. We would check again, is it lower? If yes, place it. If not, up the address, and once more. So what happens if the address is actually bigger than the buffer, or equal to the buffer? Then we place it anyway. So this should sort it. Correctly. We'll never break this loop, right? Because we have to find a clever way. Yes, this sorts it. This sorts it. Have to find a clever way to break this loop. So now it's just placing zeros. I mean, we can actually yeah, but these are sorted. These are sorted correctly. We're very close. If the RAM buffer is greater or equal to 15, export it. Else, place. Why does this happen? Does it work? Let's have a look at the export function. No, it's not going to work. Sadly, it's not going to work. But this is going to be easy. But do we jump into the export function? It's going to be interesting. So now we would theoretically jump into the export function. But we don't. Do we ever increase the buffer? Yes, we do. The moment we move the address to the buffer. is the moment we increase the buffer. Where does the buffer sit into? So we can see what will happen when the buffer reaches 15. We now import the next value. I mean, in theory, we could. This will definitely solve it. Like the moment we imported 0 is the moment we solved it. Alright, okay, we move the address to the buffer. Now it is 16. And we already imported. It's actually working. Yes, this is the highest value. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. This is 3 times 5. Yes, this is the correct solution. Now we move 0. So the RAM address. Then we move the RAM out. Then we add 1 to the RAM address. We loop. Here we are. This will solve it. It took a while. Difficult level. Took me 1.5 hours to solve this. And the solution is not even the cleanest one. 104. What is 104 divided by 4? I hope this solves it. I hope this export function is correct. We could try maybe at a later point. Yes, it solves the level. maybe at a later point we could try to, why do we have to do it 32 times? Let's go quick. Sadly we cannot watch it. Oh, there's zeros and there's actually duplicate values. We took this into account. Even though we made a lot of mistakes, this was not one of them. And we could we could try to find a better solution later on. But for now, this solves it, right? Let us look through the code once more. We move our value into the check register. Then we find the position, right? To find the position, we move the RAM address into the buffer so it doesn't get lost. Then we actually check if the buffer exceeds 15, because then if the buffer has hit 15, because then we would export. Elsewise, we move 0 to the RAM address and go into the find loop. Maybe we could call it find loop instead of find +1. And this is done by checking if the current value is lower. If so, then the value that is like our pointer, what is the pointer? The pointer is the address of the new value is lower than the value that our pointer is pointing to. And then we place it. Elsewise, we check if the pointer is lower than the buffer, like the RAM address is lower than the buffer. In case it is, we 1-up it. In case it is still lower, we would repeat the process. So this way, we would only break the loop if we find a value that is lower. If we find a value that is higher, as once we place it in the highest position. This line of code is bullshit. Yes, then we move the address to the position, because this is the position we started. Every value that is lower than the position is lower, so we don't have to take them into account. Then we just swap the two by moving one into the variable 1, then moving the checksum into the RAM, or the new value, the imported value, into the, like this could be called the new value, into the RAM, and then moving the value that was previously sitting in the RAM back into our check, so we can loop this. And we repeat this until the position, no, then we 1-up the position. And repeat this until the position is to the RAM address. The current pointer is at the highest position and like at the RAM buffer, right? And then we go back to the beginning. And then we have the export function, which is basically moving 0 to the RAM address and exporting 1 by 1 by moving them to out, then adding 1 to our pointer, and yeah, looping until we have done this and exported every single one. Nice, we solved the level. So this was IV42, long episode this time. I hope it was beneficial to you. And yes, first real assembler programming level. Exciting. It's going to become even more exciting later on. They are going to be a quite challenging level. This one wasn't even hard, but yeah. Anyway, goodbye.